Welcome to the how-to video for the AC challenge for transformers. Here is the basic formulas we'll be using for our transformer. Everything is based on our turns ratio, which is the number of turns of our primary versus the number of turns on our secondary. And our voltage is going to be a direct relationship, and our current is going to be inverse. And the best thing to do is to print out our formula sheet, and I've already done the algebra for it. So anyway, all these are going to be inverse relationships. Okay, here we are at our AC circuits challenge. And let's go to transformers. Here are our formulas and our relationships. And let's go ahead and start. So we have 960 turns to our secondary of 160. So it's going to be the same ratio. So we have, and we need to go down. So let's use 160 divided by 960. So our turns ratio is 6.16. And let's multiply that by our turns of 2400 or 240. So I have 40 volts. Okay, so if I have 40 into 240, so let's say 40 divided by 240, sorry. Yep, we had the same, good. So let's go ahead and figure out our secondary current. So we have our voltage. So I equals V over R. So we have 40 volts divided by 5 ohms. And we should have 8 amps. Okay. So our current should be lower on our primary. So let's go ahead and do 40 divided by 240 times our 8 amps, and I come up with 1.33. Okay, so our voltage ratio goes up, so our current ratio should go down. All right, here we have our current relationship, and it goes down, so our number turns should go up. So let's see here, we have 6 divided by 1.5 times 144, 576. So our turns is high to low, and here we have our current low to high. So let's go ahead and figure out our voltage on our secondary. So we have 6 amps and 6 ohms, so V equals IR. So we're going to take 6 times 6, 36 volts. Okay, so our voltage is going to be higher, so let's take 6 again. 6 divided by 1.5, 4, so 4 times 36, 144. Great. Let's go to the next problem. And we have our turns ratio and current. So since our turns ratio is from low to high, so our current is going to be from high to low. So let's go ahead and take 768 divided by 384, which is a turns ratio of 2. So let's multiply that by 7, so it should be 14 amps. Factor 2. Good. So let's figure out our secondary voltage, since we have 7 amps and 27.343 ohms. So we have V equals IR, so we have 7 times 24.3. So we got 7 times 27.43 ohms, and I got 192 volts. So our turns ratio is 1 to 2, so let's go ahead and divide 192 by 2. And our primary voltage should be 96. Good.